Before the light arrives, there is only stillness. The sandstone cliffs of the canyon stand in complete darkness, their ancient surfaces cool from the long night, holding within them the accumulated patience of millions of years of quiet geological time. The wind, when it moves at all, moves gently, a soft breath across the mesa that stirs nothing, disturbs nothing, simply passes through the darkness the way wind has always passed through this landscape, without urgency, without destination. The desert floor below is invisible. The stars above are numerous and clear, the way stars are only clear in places where human light has not yet learned to compete with them. Everything is waiting. There is no drama in this waiting. It is not the tense waiting of anticipation, not the anxious waiting of uncertainty. It is the calm, unhurried waiting of a place that has been here long enough to understand that what is coming has always come, and will always come, and requires no help from anything watching below. The sandstone simply rests in the darkness, as it has rested through every night of every season across an almost incomprehensible span of time, neither eager nor indifferent, simply present. If peaceful journeys through history and ancient landscapes help you unwind at the end of a long day, consider subscribing to History Sleepy Time and leaving a like on this video. We would love to know where in the world you are watching from tonight. Leave a comment below. Now, let us walk together into the canyon. Then, at the horizon's eastern edge, something begins. Not yet light, not in any complete sense. A suggestion of light, a slight softening of the darkness at the place where the sky meets the distant mesa, as though the night is becoming gradually less certain of itself. The stars nearest the horizon dim slightly, not extinguished, but absorbed into the growing quietness of what is approaching. The sandstone cliff face, still invisible moments before, begins to resolve itself from the darkness. Pale and enormous its surface, textured with the long patient markings of geological time. Standing at the edge of the mesa with the same unhurried dignity it has maintained through every dawn in its long history. The light arrives slowly. It does not rush. And when the first narrow beam of direct sunlight reaches the cliff, when the precise geometry of the morning sun at this particular season, in this particular landscape, sends a slender blade of gold across the ancient sandstone, something remarkable happens. Something that was not an accident. Something that someone, many centuries ago, understood with a clarity that continues to inform and quiet the imagination of every researcher who has studied it since. Every morning, the desert greets the sun. Most people simply see daylight. But for centuries, someone stood here watching something far smaller, a narrow beam of light moving slowly across stone. To them, that beam marked the passing of seasons, the turning of years, and perhaps the rhythm of an entire civilization. This is Chaco Canyon, in what is now northwestern New Mexico. And the story of what these cliffs were asked to remember is one of the most quietly extraordinary stories in the history of North America. There is a place in Chaco Canyon where the morning sun does something that no casual observer would notice without being told to look carefully. On the flat summit of a sandstone formation called Fajada Butte, a solitary, layered mesa that rises nearly 130 meters above the floor of Chaco Canyon in northwestern New Mexico. Three large stone slabs lean against the cliff face in an arrangement that appears at first glance entirely unremarkable. They are simply slabs of rock. Heavy, weathered, resting against the sandstone in the way that rock sometimes rests against rock when geological forces have gradually shifted the surface of the earth. They do not announce themselves. They do not draw the eye with any obvious sign of human intention. But behind these slabs, on the smooth sandstone surface of the cliff, someone carved two spirals. They are not large spirals. The larger of the two is perhaps 30 centimeters across, a careful, deliberate winding of carved grooves that curves inward from the outside toward a central point, executed with patience and precision in a surface of stone that required considerable effort to mark. The smaller spiral sits nearby, less elaborate but equally deliberate. They are old enough that their exact age is difficult to establish with certainty, though researchers generally associate them with the period of Chaco Canyon's greatest cultural development, roughly between 900 and 1100 years ago. For most of the year, these spirals sit in shadow for much of the day, obscured from direct sunlight by the position of the stone slabs leaning before them. But at certain specific moments that repeat with astronomical precision year after year, the gaps between the stone slabs allow narrow blades of sunlight to reach the cliff face and cross the spirals in ways that are not accidental. At summer solstice, near noon, a single narrow dagger of light descends from above and passes directly through the center of the larger spiral, bisecting it with the precision of a surveyor's instrument. The light moves slowly across the stone, crossing the center, then continuing downward in a passage that takes approximately 18 minutes to complete. During the spring and autumn equinoxes, two blades of light appear simultaneously, framing the larger spiral on either side with near-perfect symmetry. At winter solstice, the two blades of light frame the larger spiral differently again, marking the year's shortest day in a pattern as deliberate and as precise as any calendar made of paper and ink. This is what researchers and archaeologists have come to call the Sun Dagger, one of the most carefully studied examples of ancient solar observation in North America, and one of the most quietly remarkable things that human patience and astronomical understanding have ever produced. But standing here in the early morning, before the day's light has fully arrived, before the story of how this place was made and what it means has been told, the most honest response is simply to watch. To let the light move across the stone at its own pace. To notice, without immediately analyzing, what it means that someone chose this cliff, these spirals, this particular orientation of stone and shadow to mark the turning of the year. Why would someone spend generations watching a single beam of light? That question does not have a simple answer. It has, instead, a long and layered one built from geology and culture and architecture and astronomy and the patient accumulation of knowledge across centuries. To understand the Sun Dagger is to understand something about the people who made it and the place they made it in and the world they were trying to know more completely. That understanding begins not with human beings at all, but with the landscape itself, with the deep geological history of the Colorado Plateau and the particular way that time and water and pressure shaped this corner of the American Southwest into the setting that the ancestral Puebloans would one day transform into one of their greatest achievements. The story of Chaco Canyon begins, as so many remarkable stories do, with the slow, patient work of an ancient sea. The sandstone of Chaco Canyon carries within it a story far older than any human civilization. Look closely at the surface of these cliffs, at the layered bands of pale gold and dusty orange and subtle cream that run horizontally through the rock face like pages in a very old book. And what you are seeing is time made visible. Each layer is a record of a different period in the geological history of this landscape, a different set of conditions that existed here across spans of time so long that they resist easy comparison to anything in human experience. The Colorado Plateau. The vast elevated region of which Chaco Canyon is a part occupies a significant portion of what is now the American Southwest, extending across portions of Utah, Colorado, Arizona, and New Mexico in a landscape of mesas and canyons and wide desert valleys that is unlike any other geological province in North America. The rock that defines this landscape, the sandstone and limestone and shale that form the canyon walls and the flat mesa tops and the isolated buttes like Fajada, was deposited over hundreds of millions of years under conditions very different from those that exist here today. Approximately 70 to 100 million years ago, during the Cretaceous period, much of what is now the interior of North America was covered by a broad, shallow inland sea. Geologists call this the Western Interior Seaway, a body of water that at its greatest extent stretched from the Gulf of Mexico northward to what is now the Arctic, dividing the North American continent into two landmasses. In the warm, shallow margins of this ancient sea, sediment accumulated, the fine particles of sand and silt and clay carried by rivers from the surrounding highlands, settling slowly to the seafloor and building up in layers that would over millions of years be compressed and cemented into the rock we see today. The withdrawal of the Western Interior Seaway as sea levels changed and the continent continued its slow tectonic evolution, left behind these accumulated sediments, layer upon layer of marine and terrestrial deposits, recording the long succession of different environments that had occupied this region. Sand dunes that once moved across a desert landscape became, through the chemistry of pressure and time, the cross-bedded sandstone that gives the canyon walls their characteristic diagonal patterning. River deltas that once built themselves into shallow coastal waters became, through the same chemistry, the massive, uniform sandstone formations that form the great cliffs of the Colorado Plateau. The plateau itself, the elevated surface from which Chaco Canyon is carved, is the result of tectonic uplift, the same class of geological process that created the Guadalupe Mountains far to the south. Beginning roughly 60 to 70 million years ago, the land surface of the Southwest began to rise, lifted by deep geological forces that we are still working to fully understand. As the land rose, the rivers that crossed it began cutting downward more rapidly, carving into the rock with increased energy, removing material and exposing the ancient sedimentary layers below. The Colorado River and its tributaries cut the Grand Canyon in this way. The San Juan River carved its own deep valleys, and across the broader plateau, hundreds of smaller canyons, including the one that would become Chaco, were gradually excavated from the uplifted landscape by the patient, relentless work of water moving across stone. Fajada Butte, the isolated mesa at whose base the sun dagger spirals were carved, is itself a product of this differential erosion. It stands alone not because it is made of different material than the surrounding canyon walls, but because the surrounding material eroded away while a more resistant cap of rock protected the butte's summit from the worst of the weathering. The layers visible in Fajada's walls record the same geological sequence as the canyon walls on either side. The same ancient sea, the same patient accumulation, the same millions of years of pressure and chemistry transforming sediment into stone. The climate of this landscape has also changed dramatically across geological time. The warm, moist conditions of the Cretaceous gave way as the continent cooled and the inland sea withdrew to increasingly arid conditions. By the time human beings first arrived in the Southwest, somewhere between 12,000 and 15,000 years ago, following the large game animals that had themselves followed the retreating ice northward at the end of the last glacial period, the landscape was already fundamentally desert. Not the extreme desert of the Sahara or the Atacama, but the high desert of the Colorado Plateau, an environment with cold winters, hot summers, limited and unpredictable rainfall, and a remarkable diversity of plant and animal life adapted to the challenges of aridity. This is the landscape that the ancestral Puebloans inherited, not a landscape of abundance, but one of careful sufficiency, a place where the relationship between rainfall and food production was never simple or guaranteed, where the timing of planting and harvest was a matter not merely of preference, but of survival, and where the careful observation of seasonal patterns, of when the rains could be expected, of how much time remained before the growing season ended, of when the temperature would drop below the threshold that tender crops could not survive, was knowledge of immediate and practical consequence. The stone that would become the walls of Pueblo Bonito and the cliffs that would frame the sun dagger was already here, waiting, shaped by geological processes that had been operating long before any human hand reached for it. The landscape did not need to be transformed. It needed only to be understood, and that understanding, when it eventually came, produced something that the desert had not anticipated. It produced a civilization built from careful watching. The first human beings to live in the Chaco Canyon area arrived long before the great stone buildings that have made this place famous. Archaeological evidence suggests that people were present in the broader San Juan Basin, the wide, relatively flat desert region of which Chaco Canyon is a part, for several thousand years before the cultural developments that would eventually produce Pueblo Bonito and the sun dagger and the elaborate road network that connected this canyon to the wider Puebloan world. These early inhabitants were not the builders of great stone architecture. They were, in the terminology that archaeologists use, hunter-gatherers transitioning gradually toward a more settled, agricultural way of life. People who moved through the landscape following the seasonal availability of food, learning the rhythms of the desert with an intimacy that can only come from direct dependence. The cultural tradition from which the Chaco Canyon civilization eventually emerged is called the basket maker tradition, a name given by archaeologists to the early Puebloan cultural period, characterized by the production of extraordinarily fine woven baskets and other fiber goods, by the gradual adoption of maize agriculture, and by the beginning of more permanent settlement in pit houses dug partially into the earth. The basket maker people were present in the Chaco area as early as around 1500 years ago, and the evidence of their lives, the remnants of their pit houses, the deposits of their food, storage, the tools and fiber goods preserved in the dry desert conditions, gives archaeologists a picture of a community learning over generations how to inhabit a challenging landscape with increasing effectiveness. The transition from the basket maker way of life to what archaeologists call the Pueblo period, characterized by above-ground masonry architecture, more complex social organization, and the development of the great community centers like those at Chaco Canyon, was gradual and uneven. It did not happen at a single moment or in a single place. It was the accumulated result of many generations of small adaptations, improvements in agricultural technique, refinements in water management. The slow accumulation of knowledge about when to plant and when to harvest and how to store food through the lean seasons, and the development of the social structures that allowed larger communities to coordinate their activities effectively. Water management deserves particular attention in any account of how the Chaco Canyon community developed, because the relationship between water and survival in the desert Southwest is so fundamental that every other aspect of settled life depends on it. Chaco Canyon receives, on average, approximately 20 centimeters of rainfall per year, a quantity that is genuinely marginal for dryland agriculture, and that varies considerably from year to year in ways that can mean the difference between adequate harvest and serious food shortage. The ancestral Puebloans who settled in Chaco Canyon developed, over time, an impressive system of water management that allowed them to capture and direct the rainfall that the canyon received far more effectively than simple dependence on natural distribution would have allowed. They constructed earthen dams and diversion channels, features that captured runoff from the canyon rims and directed it toward agricultural fields in the canyon floor. They built bordered gardens that retained moisture and concentrated the fine silts deposited by floodwater, improving soil fertility in a landscape where fertile soil was limited. They read the landscape for signs of subsurface moisture, the presence of certain plants indicating where water collected below the surface, the particular way certain soils darkened after rain, suggesting better retention capacity, and they placed their fields accordingly. This is knowledge that does not arrive quickly. It accumulates across generations, parents teaching children what they observed, children adding their own observations, the community gradually building a body of practical ecological knowledge that no individual could develop in a single lifetime. The Chaco Canyon that we study today is the result of this accumulation of knowledge patiently gathered and carefully transmitted across many generations of careful, observant people who understood that their survival depended on understanding their landscape more completely than any casual visitor ever could. As the community at Chaco Canyon grew, as more people settled in the canyon, as agricultural techniques improved and food supplies became somewhat more reliable, as trade connections with other communities across the broader San Juan Basin developed, the scale of what was possible began to change. The small pit house communities of the earlier basket maker period gave way gradually to something larger and more ambitious, something that would require a degree of social coordination and a depth of practical engineering knowledge that the canyon had not yet seen. What emerged from this gradual process of growth and learning was one of the most remarkable concentrations of ancient architecture in North America. And understanding that architecture, what it was, how it was built, and what it tells us about the people who built it, requires us to look carefully at the great structures that still stand in Chaco Canyon today. Pueblo Bonito stands in the northern alcove of Chaco Canyon like a carefully composed thought rendered in stone. Even in its current state, partially collapsed, its rooms open to the sky after centuries of exposure to the elements, its original height reduced by time and by the slow, patient work of gravity. It is an extraordinary presence in the landscape. The D-shaped outline of the building, visible most clearly from above, curves around a large central plaza that once would have been the social heart of the community, a space for gathering, for ceremony, for the daily activities of a large and organized population. The back wall of the building, running in a long, straight line along the base of the canyon's north cliff, rises in places to 4 and 5 stories of carefully laid masonry, the stones fitted together with a precision that continues to impress architects and engineers who study it today. Pueblo Bonito, which is the largest of the structures that archaeologists call great houses, contains approximately 650 rooms arranged across multiple stories, along with around 37 kivas, the circular, semi-subterranean chambers that served ceremonial and community functions in Puebloan culture. The building was not constructed all at once. Archaeological evidence, including the use of tree-ring dating, a technique we will return to later, indicates that construction at Pueblo Bonito began sometime around 850 years of the Common Era and continued in phases over several centuries, with different sections added and modified as the community's needs and ambitions evolved. The masonry of Pueblo Bonito is one of its most immediately striking features. The builders worked with the sandstone that the canyon itself provided, blocks quarried from the canyon walls and the surrounding mesa tops, shaped with stone tools into forms suitable for construction, and laid in courses with a careful attention to both structural integrity and aesthetic consistency. The Chaco builders developed several distinct masonry styles across the period of construction, some featuring small, precisely shaped stones set in intricate patterns, others using larger blocks in more straightforward courses, and archaeologists can use the presence of these different styles within the building to trace the history of its construction phases. What the masonry cannot fully reveal, however, is the extraordinary logistical achievement that construction at this scale required. The timber used in the construction of Pueblo Bonito and the other great houses of Chaco Canyon came primarily from mountain forests that lay far from the canyon itself. Dendrochronological analysis, the examination of tree-ring patterns in the preserved timbers, has allowed researchers to identify the source forests of many of the beams used in Chaco construction, and the results are remarkable. Significant quantities of timber came from forests in the Chusca Mountains, approximately 80 kilometers to the west, and from the San Mateo Mountains to the south. These are not small distances in a landscape without draft animals, without wheeled vehicles, without any mechanized means of moving heavy loads. The transport of these timbers, some of them large ponderosa pine logs several meters in length and weighing hundreds of kilograms, across the desert landscape between the source forests and Chaco Canyon, was accomplished entirely by human effort. The logistics of organizing, moving, and delivering this material across distances that would have required multiple days of travel, even without the burden of heavy logs, speaks to a degree of social organization and collective purpose that is difficult to overstate. Current archaeological evidence suggests that Chaco Canyon, at its height of development, roughly between 900 and 1100 years of the Common Era, functioned as a regional center, a place of social, ceremonial, and probably economic significance for a much larger population than lived within the canyon itself. The Great Road network that extends outward from Chaco Canyon in multiple directions, wide, carefully constructed pathways that in some places are visible as subtle depressions in the desert surface, connected the canyon to dozens of smaller communities across the San Juan Basin. Communities that archaeologists call outlier communities. These outliers were, in various ways, connected to Chaco, sharing architectural traditions, exchanging goods, and apparently participating in whatever social and ceremonial activities the Canyon Center organized and hosted. What drew all of these communities into relationship with Chaco Canyon? What made this particular location the center of such an extensive network? Is a question that archaeologists continue to debate. The canyon is not the most fertile agricultural location in the region, nor the most easily defended, nor the most conveniently situated for access to water. What it offers, in addition to its geological setting, is something less immediately practical, but perhaps more culturally profound: a relationship with the sky that the canyon's builders recognized and deliberately cultivated. And that relationship, between the buildings of Chaco Canyon, the movement of the sun and moon across the desert sky, and the careful human observation that connected them, is the heart of what makes this place so quietly remarkable. There is a particular quality of attention that living in the desert teaches. It is not the frantic attention of a busy environment, not the constant, divided awareness required by a landscape full of competing demands. It is something quieter and more sustained than that. The desert teaches a kind of watching that is patient and methodical, that returns to the same observations day after day and season after season, that notices small changes against a background of apparent sameness, and finds in those small changes information of genuine importance. The ancestral Puebloans who built Chaco Canyon were desert people in the deepest sense, people whose relationship with the landscape around them was intimate and practical, and built from generations of careful, unhurried observation. The sun was the most reliable presence in that landscape. In a desert environment, where clouds are infrequent and the sky is clear for the majority of the year, the sun's daily and seasonal movements are more consistently visible than in almost any other climate on Earth. The arc the sun traces across the sky changes measurably from day to day, rising a little further north or south on the horizon each morning, reaching a slightly different height at midday, setting at a slightly different point each evening. These changes are gradual, and any individual change from one day to the next is subtle enough that a casual observer might not notice it. But tracked consistently, day after day, across the full cycle of a year, they describe a pattern of extraordinary regularity. The sun rises at its northernmost point on the summer solstice, the longest day of the year, when the sun traces its highest arc across the sky and the day contains its maximum hours of light. From that point, the sunrise position shifts gradually southward each morning through the weeks of summer and autumn, until it reaches its southernmost point on the winter solstice, the shortest day, when the sun traces its lowest arc and the day contains its minimum hours of light. After the winter solstice, the pattern reverses, the sunrise point moving northward again through the weeks of winter and spring, returning to the north at the following summer solstice. This cycle repeats with the same precision, year after year, across centuries and millennia, as reliable as any mechanism human beings have ever constructed. At 2 points in this annual cycle, the spring equinox in March and the autumn equinox in September, the sunrise falls at a point exactly between the summer and winter extremes, rising due east on the horizon and setting due west in the evening. These are the equinoxes, the 2 days of the year when daylight and darkness are approximately equal in duration. For an agricultural people in the desert Southwest, these 4 astronomical events, the 2 solstices and the 2 equinoxes, carried immediate and practical significance. The summer solstice marked the approximate midpoint of the growing season, a time when the monsoon rains that brought the majority of the region's annual rainfall were expected to arrive. The winter solstice marked the turning point of the cold season, the moment after which the days would begin to lengthen again, and the eventual return of planting season could be anticipated. The equinoxes bracketed the growing season itself, the spring equinox indicating the appropriate time to begin preparing fields and considering planting, the autumn equinox marking the approach of harvest and the need to complete food storage before the cold arrived. Knowing these dates with precision, knowing not just that the solstice was approaching, but that it would arrive in a specific number of days, allowed the kind of coordinated, advanced planning that large community agriculture requires. Planting cannot wait for perfect certainty. It requires prediction, and prediction requires reliable knowledge of where the season stands at any given moment. The ancestral Puebloans were not unique in their attention to astronomical cycles. Cultures around the world, across many different periods of history, developed sophisticated methods for tracking the sun's seasonal movements and using that information to organize their agricultural and social calendars. What makes the Chaco achievement particularly interesting is the specific method they employed and the degree of precision they achieved through careful attention to the relationship between sunlight and stone. Shadow watching is among the oldest and most reliable methods of solar observation available to people without manufactured instruments. When sunlight strikes a vertical surface, a cliff face, a wall, a standing stone, the shadows cast by nearby objects shift in a predictable way with the movement of the sun across the sky. The position of a shadow at a given time of day changes measurably from one day to the next as the sun's arc shifts across the seasons. An observer who marks the position of a shadow on the same surface at the same time of day on consecutive days can, over the course of a year, track the complete seasonal cycle of the sun with remarkable precision. The ancestral Puebloans appear to have understood this principle thoroughly, and they applied it not only in the construction of the sun Dagger on Fajada Butte, but in the orientation and design of the great houses themselves. Pueblo Bonito's principal walls are aligned with the cardinal directions north, south, east, and west, with a precision that researchers have confirmed through careful modern survey. The long, straight rear wall of the building runs precisely east to west, oriented to align with the rising and setting sun on the equinoxes. Other architectural features within the canyon show alignments with the solstices, doorways positioned to admit the first light of the winter solstice sunrise, walls oriented to align with the summer solstice sunset, room arrangements that would have created specific shadow patterns at astronomically significant moments. These alignments are not coincidental. The mathematical precision required to achieve them to orient a wall exactly east to west. To position a doorway so that the winter solstice sunrise casts its light through a specific opening in a specific way requires deliberate planning and careful observation conducted over a considerable period of time. You cannot align a building with the equinox sunrise without first knowing exactly where the equinox sunrise falls on the horizon. And knowing where the equinox sunrise falls requires watching the horizon morning after morning across at least one complete annual cycle, marking the sun's position at each day's sunrise and identifying the point where it rises due east. This is the connection between the great architecture of Chaco Canyon and the small spirals carved on the cliff of Fajada Butte. Both represent the application of the same fundamental knowledge, the precise, carefully observed understanding of the sun's seasonal movements to different purposes and at different scales. The architecture organized the community's relationship to the sky in space. The spirals recorded it in time, and it is the spirals, the sun Dagger, that bring this long accumulation of astronomical knowledge into its sharpest and most intimate focus. On the morning of June 29, 1977, an artist named Anna Sophia was climbing the steep face of Fajardo Butte. She was not, at that moment, thinking about astronomy. She was participating in a survey of rock art in Chaco Canyon, the systematic documentation of the petroglyphs, the carved and pecked images that appear on stone surfaces throughout the canyon and the surrounding landscape, as part of a volunteer recording project. The work involved careful climbing and careful looking, moving across the canyon's rock faces with attention to the surfaces around her, recording what she found. Near the top of Fajardo Butte, in the late morning, she noticed something. 3 large sandstone slabs leaned against the cliff face, their position apparently the result of natural geological processes. The gradual movement and settling of rock on the butte's steep upper surface. Behind these slabs, on the smooth cliff face, were 2 spirals, a larger and a smaller, carved in a style consistent with the broader rock art traditions of the Chaco Canyon area. Sophia had encountered petroglyphs before in the course of the survey. But what she noticed near these spirals was something she had not seen before. A narrow blade of sunlight, passing through the gap between 2 of the stone slabs, was moving slowly downward across the cliff face, crossing the larger spiral in a way that seemed, to her eye, deliberate. The light moved. The spiral waited. And in the time it took to understand what she was watching, the blade of light had passed through the center of the spiral with a precision that seemed to exceed what accident could reasonably produce. Anna Sophia returned to Fajardo Butte. She returned at different times of day and at different times of year, bringing colleagues and instruments and the careful, patient attention that a genuine scientific inquiry requires. What she and her collaborators documented across those return visits was the complete picture of what the sun Dagger represents, the full range of solar events marked by the movement of light through the stone slabs across the larger and smaller spirals throughout the annual cycle. The summer solstice bisection, the equinox framings, the winter solstice pattern marking the year's shortest day. The findings were remarkable enough that Sophia and her collaborators published them in the journal Science in 1979, introducing the sun Dagger to the broader scientific community and beginning what would become decades of ongoing research, debate, and deepening understanding of what this site represented. The scientific community's initial response included the careful skepticism that genuine inquiry requires. Some researchers questioned whether the alignment of the stone slabs with the solar events was the result of deliberate human placement or of natural geological coincidence, whether the slabs had fallen or shifted into their current position by chance, and whether the spiral petroglyphs had simply happened to align with the light patterns that resulted. This is a reasonable question to ask of any proposed astronomical alignment in the archaeological record, and it deserved careful investigation. The investigation that followed was methodical and thorough. Researchers examined the stone slabs and their relationship to the cliff face with attention to the geology of the butte, looking for evidence of whether the slab's current position was geologically natural or the result of human intervention. They examined the spiral petroglyphs themselves, looking at their position, size, and orientation relative to the light patterns. They conducted precise measurements of the light patterns at each of the astronomical events they claimed the site marked, documenting the alignments with the kind of photographic and instrumental evidence that allows independent verification. The weight of the evidence supported the conclusion that the sun dagger was deliberate. The precision of the solar alignments, particularly the summer solstice bisection, in which the light blade passes through the exact center of the larger spiral with a precision measurable in fractions of a centimeter, is difficult to explain as coincidence. The placement of the spirals on the cliff face and their size and position relative to each other is consistent with a design intended to interact with the light patterns in exactly the ways observed. The stone slabs themselves show evidence of having been placed or adjusted by human hands. Their current position is not entirely consistent with simple geological fall, and there are signs that they were arranged with intention. Anna Sophia went on to found the Solstice Project, a non-profit organization devoted to the continued documentation and study of Chaco astronomical knowledge. Not only the sun dagger on Fajardo Butte, but the broader pattern of solar and lunar alignments evident in the architecture of Chaco Canyon's great houses. Her work has been both influential and occasionally controversial within the archaeological community. Some researchers have accepted her interpretations of architectural alignments. Fully others have suggested that some alignments may be more coincidental than intentional. And the scholarly conversation about the precise degree of astronomical intentionality in Chaco design continues today. This is how archaeological science is supposed to work. Not with simple consensus or simple dismissal, but with careful examination of evidence, honest acknowledgement of uncertainty, and the patient accumulation of data that allows interpretations to be refined over time. What no serious researcher disputes is that the sun dagger site on Fajardo Butte represents a genuine solar calendar, a deliberate human creation designed to mark the solstices and equinoxes with remarkable precision, and that this represents one of the most sophisticated examples of ancient astronomical observation in North America. There is something deeply moving about the story of Anna Sophia's discovery, not because it was dramatic, which it was not, but because of what it represents about the relationship between careful attention and knowledge. She was not looking for the sun dagger. She was simply looking carefully at what was in front of her. And because she was paying attention, because she noticed the light moving across the spiral and recognized that what she was seeing deserved further observation, something that had been waiting for recognition for nearly 900 years was finally seen again by human eyes. That quality of attention, of noticing and returning and watching again, is the same quality that created the sun dagger in the first place. And understanding how it was created, what combination of observation, planning, and patient engineering produced such a precise result, requires us to think carefully about what engineering means when the only materials available are stone, sunlight, and time. Consider for a moment what it would require to build the sun dagger, not to imagine it, not simply to conceive of the idea that sunlight might be made to mark the solstice on a carved spiral, but to actually execute it. To take that idea from concept to reality, in stone, in a landscape without metal tools, without manufactured measuring instruments, without written calculations, without any of the technical apparatus that modern engineering takes for granted. To produce, at the end of the process, a solar calendar accurate enough that the summer solstice light blade bisects the center of a spiral with the precision that modern measurements confirm. Where does such a project begin? It begins, as so many genuinely difficult achievements begin, with observation. Long before any stone is placed or any spiral is carved, someone must watch. They must watch the sun rise on consecutive mornings, noting where on the horizon it appears and how that position shifts from day to day. They must watch the shadows cast by the cliff face at different times of day across different seasons, noting how those shadows change as the sun's arc changes. They must identify, through this patient watching, the specific times of year when the sun's position produces particular shadow patterns in a particular location. And those times of year are precisely the solstices and equinoxes. This observational phase cannot be rushed. A complete annual cycle is the minimum requirement. You cannot know where the summer solstice sunrise falls on the horizon without watching through at least one complete year. But a single year's observation is not sufficient to establish the kind of precision that the sun dagger demonstrates. 1 year of watching gives you an approximate answer. Multiple years of watching, comparing the observations of 1 year against those of another, refining your understanding of the exact dates and shadow positions. This is what produces precision. Researchers who have studied the sun dagger and the broader pattern of astronomical observation at Chaco Canyon generally conclude that the knowledge embodied in these sites accumulated over many generations. The individual who carved the spirals on Fajada Butte was not working from scratch. They were working from a tradition of astronomical observation that had been developing in the Puebloan world for a considerable period. A tradition in which the relevant observations had already been made, the important relationships between sun position and shadow pattern had already been identified. And the task was to find a specific location where those relationships could be made visible in stone in a particularly precise and durable way. Finding that location was itself a significant achievement. The position on Fajada Butte, where the stone slabs stand, is not a random cliff face. It is a specific location where the natural geometry of the butte's rock surface, the angle of the cliff, the presence of a suitable smooth area for the spirals, and the specific configuration of the existing stone slabs allows the summer solstice sunlight to arrive at the spiral from exactly the right angle to produce the bisecting light blade. Other positions on the butte or on other cliffs in the canyon would produce different light patterns that would not align with the carved spirals in the same precise way. Selecting this location required the observers to move across the landscape with an experimental eye to test different cliff faces and different times of day, to look for the natural configuration that best served the astronomical purpose. This is not a process that produces results quickly. It is a process of systematic exploration and patient testing, guided by accumulated knowledge and refined by careful observation. The engineering of the spirals themselves reflects a sophisticated understanding of what the final product needed to accomplish. The size of the larger spiral, approximately 30 centimeters across, is precisely appropriate for the width of the light blade that the stone slab gap produces at the summer solstice. A smaller spiral would be bisected by the light blade less clearly. A larger spiral would make the bisection less precise. The position of the two spirals relative to each other is also deliberate. The smaller spiral participates in the equinox light pattern in a way that complements the larger spiral's role in the solstice marking. The carving of the spirals was accomplished with stone tools, most likely harder stone implements used to peck and grind the softer sandstone of the cliff face. This is time-consuming work, and it requires both physical patience and a clear understanding of the final form that the carving must take. The spiral is a demanding shape to execute with precision in stone. It requires maintaining consistent spacing between the carved grooves as the spiral turns inward, and keeping the overall form regular enough that it reads clearly as a deliberate geometric shape rather than an irregular marking. The broader pattern of solar alignment in Chaco Canyon's great houses represents engineering of a different scale, but the same fundamental character. Orienting a large masonry building precisely east to west requires establishing true east, the direction of the equinox sunrise, with sufficient accuracy to serve as a building guide. This can be accomplished through careful horizon observation across multiple equinox sunrises, marking the sunrise point on the horizon and using that mark to establish the building's orientation. But it requires the observations to be made and the orientation to be established before construction begins, integrating the astronomical work into the planning process rather than attempting to adjust the building after the fact. The integration of astronomical knowledge into architectural planning suggests that the Chaco builders did not think of astronomy and architecture as separate activities. For them, building was a form of observation made permanent, a way of fixing in stone the astronomical relationships that careful watching had revealed. The great houses were not simply shelters or community centers. They were instruments, in the broad sense of that word, structures designed to interact with the sky in specific and meaningful ways, encoding the community's astronomical knowledge into the landscape in a form that would outlast any individual observer. This is a way of thinking about engineering that differs from the modern conception in a manner worth pausing to appreciate. Modern engineering typically begins with a problem to solve and applies technical knowledge to solving it. Chaco engineering began with an observation to preserve and built structures capable of preserving it. The engineering served the observation rather than the observation serving the engineering. Could architecture become a way of measuring time? At Chaco Canyon, the evidence suggests that it already had. The canyon holds more than stone and shadow. It holds memory, the living, continuing memory of the people who built here, whose descendants still walk the landscape of the American Southwest, and who maintain traditions of knowledge and practice that connect them across the centuries. to the civilization whose physical remains we have been tracing through this documentary. The ancestral Puebloans of Chaco Canyon were not a vanished people in any complete sense. Their descendants are the Pueblo peoples of New Mexico and Arizona, the Hopi, the Zuni, the Keres-speaking peoples, the Tewa, the Tiwa, and others, communities with living cultures, active traditions, and a continuous relationship to the history and landscape of which Chaco Canyon is a part. This is an important distinction to hold carefully. When archaeologists study the ruins of Pueblo Bonito, they are studying the physical remains of the ancestors of living people who have their own understanding of and relationship to those remains. The perspectives of contemporary Pueblo communities on Chaco Canyon are not simply supplementary to the archaeological record. They are part of the full picture of what this place is and what it means. Many contemporary Pueblo peoples regard Chaco Canyon as a sacred place, a landscape of deep spiritual and cultural significance, associated with origin stories and migration narratives that are central to their sense of identity and history. The specific content of these traditions varies among different Pueblo communities, and many aspects of sacred knowledge are not shared publicly, belonging to the ceremonial life of the community rather than to the broader domain of public discourse. This is a boundary that deserves to be respected, and this documentary will not attempt to cross it. What can be said respectfully and in general terms is that oral traditions among various Pueblo peoples describe Chaco Canyon as a place of great importance to their ancestors, a center of gathering, of ceremony, of the kind of communal activity that brought people together from a wide surrounding region. These traditions describe a time of coming together in this place, and they also describe a time of departure, a movement away from Chaco Canyon toward the communities where Pueblo peoples live today. A migration that is understood within these traditions as part of the larger story of the people's journey through time. Archaeologists generally agree that Chaco Canyon's period of greatest activity as a regional center ended sometime in the 12th century of the Common Era, roughly 800 to 900 years ago, and that the canyon was largely depopulated by the mid-12th century. Though the causes and character of this depopulation are subjects of ongoing scholarly debate, the oral traditions of contemporary Pueblo peoples, which describe a departure from the canyon rather than a catastrophic end, align in their general outline with the archaeological picture of a gradual dispersal rather than a sudden collapse, though the two types of evidence are not identical and should not be conflated. The relationship between the sun Dagger and the ceremonial life of the Chaco community is a subject on which oral traditions and archaeological evidence both have something to offer, though what they offer is different in character. Archaeological evidence demonstrates that the sun Dagger site was used to mark astronomical events of practical importance, the solstices and equinoxes, in a form that would have been accessible to the community's leadership or to specialized observers whose role it was to track the solar calendar. The practical function of this knowledge, its relevance to agricultural timing, to the coordination of communal activities, to the planning of the ceremonies and gatherings that the great houses were apparently designed to host, is directly supported by the evidence. What oral traditions from various Pueblo communities suggest, and it is important to say clearly that these traditions should not be treated as direct historical documentation of Chaco practice, is that the relationship between the sun, the seasons, and human ceremony was not understood as merely practical in the modern sense. The sun was not simply a clock to be read for agricultural convenience. It was a participant in the life of the community, a presence whose movements marked not only the appropriate times for planting and harvesting, but the appropriate times for ceremony, for prayer, for the renewal of the community's relationship with the world around it. The spirals on Fajada Butte, in this broader understanding, may represent something more than an efficient solar calendar. They may represent a point where the practical and the ceremonial intersected, a place where the knowledge of the sun's movements was made visible in a form that served both the agricultural calendar and the deeper cultural life of the community that observed it. It is worth holding this possibility gently without forcing it into certainty that the evidence does not support. Archaeological evidence tells us what the sun dagger does. It marks the solstices and equinoxes with great precision. It does not tell us, in any direct way, what it meant to the people who made it and used it. For that dimension of the story, for the question of meaning rather than mechanism, we must turn to the living traditions of the people whose ancestors built this place, and listen with the respect and humility that living knowledge deserves. The desert sky above Chaco Canyon has witnessed both dimensions, the precise astronomical knowledge encoded in stone, and the human lives lived in relationship to that knowledge across centuries. Both dimensions are real. Both deserve careful attention. And in the decades since the sun dagger was first documented by Anna Sophia, science has developed increasingly sophisticated tools for exploring what remains of the physical record that the canyon preserves. There is a particular satisfaction in watching two very different kinds of knowledge arrive at the same conclusion by different paths. Modern archaeology has returned to Chaco Canyon many times since the first systematic excavations of the late 19th and early 20th centuries, and each return has brought with it new tools, new questions, and a deepening appreciation for the complexity of what was built here. The canyon has not become less interesting with familiarity. If anything, the accumulating weight of careful research has made it more interesting, revealing layers of intentionality and sophistication in the Chaco achievement that earlier generations of researchers, working with more limited methods, could not fully perceive. The history of archaeological work at Chaco Canyon is itself a story worth pausing over briefly. Richard Wetherill, a rancher and self-taught explorer from Colorado who had made his name in the 1880s and 1890s through the documentation of cliff dwellings at Mesa Verde to the north, was among the first to conduct systematic excavation at Pueblo Bonito in the late 1890s and early 1900s. Wetherill's work was pioneering in many respects. He recognized the significance of what he was finding. He kept detailed records by the standards of his time, and he recovered an enormous quantity of material that gave early researchers their first detailed picture of Chaco life. But his methods, judged by modern standards, were extractive in ways that caused irreversible loss. Objects removed from their original context, stratigraphic relationships between layers of deposit disrupted, material distributed to museums and private collections in ways that make comprehensive analysis difficult today. The history of early archaeological practice at sites like Chaco Canyon is a history that the discipline of archaeology has spent considerable effort understanding and learning from. The shift from extraction to documentation, from the removal of objects to the careful recording of context, represents one of the most significant methodological transformations in the history of the field, and it has profoundly changed what archaeology can tell us about the past. Modern excavation at Chaco Canyon proceeds with extreme caution and is conducted only when specific scientific questions require it, and when non-invasive methods cannot provide the needed information. Because the preference in modern archaeological practice is strongly toward non-invasive investigation whenever possible, the tools that have transformed our understanding of Chaco Canyon in recent decades are largely tools that examine what is there without disturbing it. Dendrochronology, tree ring dating, has been one of the most productive of these tools in the Chaco context. The American Southwest is one of the best places in the world for dendrochronological research, because the combination of climate variability and dry preservation conditions produces both clear tree ring records and excellent organic preservation of the wooden materials found in archaeological sites. The ring patterns of the preserved timbers in Chaco Canyon's great houses have been read with sufficient precision to identify not only the general period of construction, but in many cases, the specific decade or even the specific years during which particular building phases occurred. The dendrochronological record from Chaco Canyon tells a story of construction that unfolded across centuries, with distinct periods of intensive building activity separated by intervals of slower development. It also tells a story of climate, because tree ring widths reflect the rainfall and temperature conditions of each growing season. The same ring sequences that date the timbers also provide a record of climatic conditions across the period of Chaco development. This record reveals that the 12th century, the period during which Chaco Canyon's role as a regional center appears to have diminished, was marked by a severe and prolonged drought. A period of significantly reduced rainfall that would have placed enormous stress on the agricultural systems that supported the canyon's population. The relationship between this climatic downturn and the depopulation of Chaco Canyon is a subject of active research and careful debate. It is clear that the drought was real and that it was severe. What is less clear is the precise mechanism by which climatic stress translated into social and demographic change, whether the population moved away in a deliberate and organized response to declining agricultural conditions, whether the social systems that had organized the canyon's community proved unable to sustain cohesion under stress, or whether some combination of environmental and social factors produced the dispersal that the archaeological record documents. What the dendrochronological record makes clear is that the builders of Chaco Canyon were not operating in a static environment. They were responding generation by generation to a landscape that changed, that had better years and worse years, wetter periods and drier ones, and their architectural and agricultural achievements need to be understood in the context of this environmental variability rather than against a background of assumed climatic stability. Remote sensing technologies have added another dimension to modern Chaco research. LIDAR, light detection and ranging, is a technique that uses laser pulses from aircraft to measure the precise elevation of the ground surface across large areas, producing three-dimensional maps of remarkable resolution and accuracy. In landscapes like Chaco Canyon, where centuries of wind-blown sediment and biological growth have partially obscured surface features, LIDAR can reveal subtle topographic signatures that are invisible to ground-level observation or conventional aerial photography. LIDAR surveys of Chaco Canyon and the surrounding region have revealed details of the road network, the system of carefully constructed pathways that connected the canyon to its outlier communities that were not fully appreciated from ground survey alone. The roads, which in some sections are remarkably well preserved and clearly visible as linear depressions or raised berms in the desert surface, in other sections had been obscured by erosion and vegetation growth to the point of invisibility. LIDAR has recovered portions of this network, allowing researchers to trace its extent and character with greater completeness than was previously possible. The Chaco roads are themselves one of the more intriguing features of the canyon's archaeological landscape. They are not roads in the modern sense. They do not appear to have been designed primarily for wheeled vehicles, which did not exist in pre-Columbian North America, or for large animal transport, since the ancestral Puebloans did not use draft animals. They are wide, some sections are nearly 9 meters across, far wider than practical foot travel would require, and they are remarkably straight, maintaining their linear course across the landscape, even where topographic features like arroyos or small ridges would have made slight deviation easier. Where the roads encounter significant topographic obstacles, the builders sometimes cut steps into the rock face rather than deviating from the straight line. This insistence on straightness, on maintaining a precise bearing across the landscape regardless of the terrain, has led researchers to consider the roads in a context that goes beyond simple transportation. The combination of width, straightness, and the effort invested in their construction suggests that the roads may have served purposes that were as much ceremonial or symbolic as they were practical, that moving along them was itself a meaningful activity, a way of traversing the landscape in a manner that embodied a particular relationship between the community and its territory. The astronomical orientation of some road segments has also been noted. Certain sections of the Chaco road network align with solstice or equinox directions that would have placed the traveler moving along the road in a specific astronomical relationship with the Sun at specific times of year. Whether these alignments are deliberate or coincidental is, like many questions about Chaco intentionality, a matter of ongoing scholarly discussion. But they fit a pattern visible across the architecture, the road network, and the sun dagger of a community whose relationship with the sky was woven into the physical fabric of its landscape at multiple scales. Archaeoastronomy, the study of astronomical knowledge and practice in ancient cultures, and of the ways that astronomical understanding shaped the built and natural environments that ancient peoples created, has developed significantly as a discipline since Anna Sofia's 1977 discovery on Fajada Butte. The field brings together archaeology, astronomy, architecture, and anthropology in an interdisciplinary conversation that has produced increasingly refined understanding of what the astronomical features of Chaco Canyon represent and how they relate to similar practices in other cultures around the world. One of the more significant findings of recent archaeoastronomical research at Chaco Canyon is the documentation of lunar alignments in the Great House architecture. The moon's movement across the sky follows a cycle more complex than the sun's over a period of approximately 6 years. The moon's rising and setting positions on the horizon trace a range that is wider than the sun's annual range, reaching maximum northern and southern extremes called the major lunar standstills at the cycle's endpoints. Researchers have identified architectural features in several of Chaco Canyon's great houses that appear to align with the major lunar standstill positions, suggesting that the Chaco builders tracked not only the annual solar cycle, but the longer lunar cycle as well. If this interpretation is correct, and the evidence for it, while compelling to many researchers, remains a subject of scholarly evaluation, it suggests that the astronomical knowledge embedded in Chaco architecture is even more sophisticated than the solar alignments alone would indicate. Tracking the 6-year lunar cycle requires either an exceptionally long tradition of careful observation or a mathematical understanding of the moon's movement sufficient to predict its standstill positions without observing the complete cycle. Either possibility speaks to a depth of astronomical knowledge that commands genuine respect. Preservation science has also become an increasingly important dimension of Chaco research. The structures of Chaco Canyon are vulnerable to the same forces that have shaped the landscape around them across geological time: wind, water, frost, and the slow chemistry of weathering that returns stone to soil. The masonry of the great houses, which survived for nearly 1,000 years in the dry conditions of the canyon, faces accelerating challenges in the modern era. From the increasing numbers of visitors whose footsteps and breath and physical presence affect the microclimate of sensitive areas, and from the broader environmental changes that are altering precipitation patterns and temperature extremes across the American Southwest. The National Park Service, which manages Chaco Culture National Historical Park as a unit of the National Park System, works continuously on the stabilization and conservation of the canyon's structures. The work is technically demanding, consolidating loose masonry redirecting water away from vulnerable wall sections, monitoring the structural condition of buildings that have been partially collapsed for centuries, and it requires ongoing attention and resources. Chaco Canyon was designated a UNESCO World Heritage Site in 1987 in recognition of its outstanding universal value as an archaeological landscape of global significance. And this designation brings with it both international attention and international responsibility. The researchers who work in Chaco Canyon today, the archaeologists, the archaeoastronomers, the dendrochronologists, the geologists, the conservation specialists, are aware that they are working in a landscape whose full story has not yet been told. Each season of fieldwork adds something to the understanding of what was built here and why. Each new analytical technique applied to the existing collections of material from the canyon yields information that was not accessible to the researchers who came before. And each conversation between scientific research and the living traditions of contemporary Pueblo peoples adds a dimension of meaning that scientific data alone cannot provide. The story of Chaco Canyon is still being written carefully, collaboratively, with the appropriate humility of people who know that they are working at the edge of what the available evidence can tell them, and who respect the boundary between what is known and what remains for now beyond knowing. For all that careful scholarship has revealed about Chaco Canyon in the century and more since systematic research began here, some of the most fundamental questions about this place remain genuinely open. The question of population is perhaps the most basic of these. How many people actually lived in Chaco Canyon at the height of its development, during the 10th and 11th centuries, when construction was most active and the canyon's role as a regional center was most pronounced? This seems like it should be an answerable question. Count the rooms, estimate how many people a room could house, and you have a population estimate. But the reality is considerably more complicated than that simple calculation suggests. Many of the rooms in Chaco Canyon's great houses show limited evidence of habitation, sparse deposits of domestic material, few hearths, little of the accumulated debris that occupied rooms accumulate over time. Some researchers have interpreted this as evidence that the great houses were not primarily residential structures at all, that they functioned instead as storehouses, ceremonial centers, or places of temporary gathering during communal events. With the permanent residential population of the canyon being considerably smaller than the room count alone would imply. Other researchers have argued that the absence of domestic material in certain rooms reflects the high status of the buildings and the careful maintenance practices of their inhabitants, rather than a lack of habitation. High-status residences in many cultures are kept cleaner than ordinary ones, and the material signature of their occupation is correspondingly less visible in the archaeological record. Current scholarly opinion leans toward the interpretation that Chaco Canyon was not as densely populated as its room count might suggest, that the permanent residential population was in the hundreds rather than the thousands. With the canyon's significance as a regional center, drawing much larger numbers of people for periodic gatherings, rather than supporting a large permanent community. But this interpretation is not universally accepted, and the population question remains one of the more actively debated aspects of Chaco archaeology. The question of social organization is equally complex. What kind of society built and maintained Chaco Canyon? Was it organized hierarchically with a ruling class that commanded the labor and resources of a subordinate population? Was it more egalitarian, with the great construction projects representing voluntary collective effort organized around shared ceremonial commitments? Or was it something in between, a society with meaningful distinctions of status and authority, but without the sharp stratification of a class-based system? The material evidence from Chaco Canyon offers hints rather than clear answers. Certain burials found in Pueblo Bonito, individuals interred with unusually rich assemblages of turquoise, shell jewelry, and other valuable goods, suggest that some people in Chaco society accumulated material wealth and social status in ways that others did not. The presence of exotic goods at Chaco Canyon, turquoise from mines in the Cerrillos Hills near present-day Santa Fe macaw feathers, and copper bells from Mesoamerica. Shell from the Pacific and Gulf coasts indicates participation in long-distance trade networks that connected Chaco to a world far larger than the San Juan Basin. The organization and control of these trade networks would likely have been associated with social authority of some kind. But the nature of that authority, whether it was hereditary, achieved, religious, political, or some combination of these, is not something the material record can tell us directly. Social organization leaves traces in the archaeological record, but those traces are difficult to interpret with confidence, and the interpretations that different researchers offer for the same evidence can differ substantially. The trade networks themselves raise questions that are only partially answered by the current evidence. The volume of turquoise found at Chaco Canyon, tens of thousands of pieces, in various stages of manufacture, suggests that the canyon was not simply a consumer of this material, but a center for its processing and redistribution. The presence of macaw remains, the bones of scarlet macaws, birds native to tropical Mesoamerica and not to the American Southwest, in significant quantities at Chaco Canyon, suggests either direct trade with Mesoamerican cultures or the operation of an intermediate trade network that carried these birds northward through multiple exchanges. Whether these trade connections involved the direct movement of Chaco people to Mesoamerica, or of Mesoamerican people to Chaco, or simply the movement of goods through intermediate networks, is a question that the evidence has not yet resolved. Some researchers have proposed that Chaco culture shows significant Mesoamerican influence in its architecture, its cosmology, its ceremonial practices, while others have argued that the parallels are superficial and that Chaco civilization developed from indigenous southwestern traditions without substantial Mesoamerican input. This debate continues, and new evidence from ongoing research continues to inform it without yet producing a settled conclusion. The question of what ended Chaco Canyon's period as a regional center is, as mentioned earlier, associated with the severe drought documented in the dendrochronological record of the 12th century. But climate alone may not be a sufficient explanation. The Colorado Plateau has experienced droughts before and after the Chaco period, and not all of them produced comparable social disruption. The particular vulnerability of the Chaco system to the 12th century drought, if vulnerability is indeed what the depopulation of the canyon reflects, may have had as much to do with the social and political organization of the system as with the severity of the environmental stress. Some researchers have proposed that the Chaco system was already under internal stress before the drought, that the enormous investment in construction and the demands of maintaining the regional network had placed strains on the agricultural base that supported the population, leaving the system with limited resilience when climatic conditions deteriorated. Others have suggested that the depopulation of Chaco Canyon was less a collapse than a reorganization, that the people moved away from the canyon but maintained their cultural traditions and social connections in new locations, and that the communities they established after leaving Chaco represent continuity rather than discontinuity with the Chaco achievement. The oral traditions of contemporary Pueblo peoples, which describe a purposeful departure rather than a catastrophic end, support the continuity interpretation in general terms. The archaeological record of post-Chaco communities in the Rio Grande Valley and elsewhere in the southwest shows clear cultural connections to the Chaco tradition, architectural styles, ceramic traditions, astronomical practices that speak to the survival and continuation of knowledge and practice rather than their extinction. These are questions that deserve the continued attention of careful researchers, and that deserve to be held with the intellectual honesty of people who recognize that the available evidence does not yet support definitive answers. The uncertainty is not a failure of research. It is an honest reflection of the limits of what the past has left behind for the present to examine. And within those limits, what has been found is already remarkable enough to ask a final, larger question. Why does Chaco Canyon matter, not only to the researchers who study it, or to the Pueblo peoples whose heritage it represents, but to the broader world of people who may never visit this canyon or encounter its ruins in any direct way? The answer to that question begins with something simple. Chaco Canyon matters because it is true, because it actually happened, because in a specific location in the high desert of northwestern New Mexico, a group of human beings, without metal tools, without manufactured instruments, without writing, without any of the technological apparatus that modern civilization considers essential to sophisticated achievement, built something of extraordinary precision and complexity, and embedded within it a knowledge of the natural world that required generations of careful, patient observation to accumulate. The sun dagger on Fajada Butte is not a remarkable achievement because it is mysterious, or because it defies explanation, or because it requires any extraordinary hypothesis to account for it. It is remarkable precisely because it does not require any of those things. It is the product of human attention, applied consistently and patiently to the observable world over a long period of time. It demonstrates that careful observation, sustained across generations, can produce knowledge of genuine precision and practical value, and that this knowledge can be embodied in stone in ways that endure for centuries. This is a lesson about human capability that does not age. It does not depend on the particular cultural context of the ancestral Puebloans or on the specific astronomical application they found for their accumulated knowledge. It is a lesson that speaks to something universal in human experience, the capacity of careful, sustained attention to reveal genuine understanding of the world. In an era when the pace of information exchange is faster than at any previous point in human history, and when the kind of patient, multi-generational observation that produced the sun Dagger is increasingly difficult to sustain in any institutional or social context, the Chaco achievement offers a quiet reminder of what slow, careful watching can produce. The builders of Chaco Canyon did not have the option of quick results. They worked with the pace that stone and sunlight allowed, which is to say, they worked very slowly across timescales that required trust in the people who would come after them, and a commitment to knowledge that extended beyond any individual lifetime. Chaco Canyon also matters as a demonstration of what is possible in the absence of the resources we typically consider necessary for large-scale achievement. The great houses of Chaco Canyon were built without metal tools. The cutting, shaping, and placement of hundreds of thousands of sandstone blocks, accomplished with tools of harder stone and the patient labor of human hands. The timber was transporting without wheeled vehicles or draft animals, carried on human shoulders across dozens of kilometers of desert landscape. The astronomical alignments were achieved without manufactured instruments, established through the careful observation of shadows and horizon positions across many seasons of watching. This is not a romantic argument that ancient methods were superior to modern ones, or that technology is unnecessary for human achievement. It is simply the observation that the Chaco achievement is a demonstration of what human beings can accomplish when they apply sustained collective effort, practical knowledge, and careful organization to a shared purpose, regardless of the specific technological context in which they work. For contemporary archaeology, Chaco Canyon is one of the most important research sites in North America, a place where questions about social organization, environmental adaptation, astronomical knowledge, and long-distance cultural connection can be investigated through a material record of unusual richness and quality. The ongoing research at the canyon continues to produce new findings, and the application of new analytical techniques to existing collections continues to reveal information that was not accessible to earlier researchers. For indigenous communities, particularly for the Pueblo peoples of New Mexico and Arizona, whose ancestors built here, Chaco Canyon is a place of living cultural significance that exists in a relationship of continuity rather than simply of historical interest. The knowledge traditions, ceremonial practices, and cultural values that the Chaco builders embodied in stone are not entirely lost. They survive in various forms in the living communities whose heritage this landscape represents. The relationship between the archaeological study of Chaco Canyon and the cultural traditions of contemporary Pueblo peoples is one of the most important and most carefully navigated conversations in contemporary American archaeology. A conversation that requires mutual respect, genuine listening, and a willingness on the part of researchers to acknowledge that the scientific study of the past is not the only form of knowledge about it that deserves respect. For the world's understanding of ancient astronomy, of how human beings across many different cultures and historical periods developed sophisticated knowledge of the sky through careful observation. Chaco Canyon is one of the clearest and most thoroughly studied examples available. The precision of the Sun, Dagger's solar alignments, the lunar alignments proposed for the Great House architecture, and the broader pattern of astronomical intentionality that researchers have documented across the canyon's built environment, together constitute one of the richest bodies of evidence for ancient astronomical practice in the Western Hemisphere. Chaco Culture National Historical Park's designation as a UNESCO World Heritage Site in 1987 reflects the international recognition of the canyon's significance, not only for American history or for the heritage of Pueblo peoples, but for the broader human story. The citation for the designation describes Chaco as a place of outstanding universal value, recognizing that what was achieved here speaks to something in the human experience that transcends cultural and geographic boundaries. That something is the relationship between careful observation and understanding. It is the recognition that the natural world contains patterns in the movement of the sun and moon, in the rhythm of the seasons, in the relationship between rainfall and plant growth that can be perceived and understood and used by human beings who pay close enough attention for long enough. It is the quiet demonstration that knowledge does not require laboratories or libraries or the accumulated technological apparatus of modern science. It requires, at its most fundamental, the same thing it has always required: attention, patience, time, and the willingness to return, day after day and season after season, to the same cliff, the same shadow, the same slow movement of light across stone, until what was once simply a beam of sunlight becomes something more, until it becomes knowledge, until it becomes, in the hands of patient builders working across generations, a calendar carved in stone that will continue to mark the turning of the year long after the hands that carved it are gone. That is what Chaco Canyon is. That is why it still matters. And as another season turns across the high desert of New Mexico and the angle of the morning sun shifts by its daily increment toward the next solstice, the canyon's stones continue their patient, unhurried work, keeping time as they have kept it for nearly 1,000 years. In the quiet language of light and shadow, there is a particular quality to the light in Chaco Canyon just before the sun completes its morning arrival. It is the same light that opened this journey, the same slow amber warmth moving across pale sandstone, the same long shadows retreating from the canyon floor as the sun climbs above the eastern mesa, the same quiet transformation of darkness into the particular golden clarity that belongs only to desert mornings. But having traveled the full length of this story, from the ancient sea that deposited the stone through the generations of careful builders who shaped it through the astronomical knowledge encoded in its walls and spirals. Through the modern science that continues to read what was written here, the light looks different now, not more dramatic, not more startling or more intense than it was at the opening of this journey, simply more complete. The light is the same light it has always been. What has changed is the quality of attention brought to it. This is, perhaps, the most honest thing that can be said about what Chaco Canyon offers to anyone who takes the time to engage with it carefully. The canyon does not reveal new things so much as it deepens the seeing of what is already there. The sandstone cliffs were always this old. The spirals on Fajada Butte were always this precisely positioned. The alignment of Pueblo Bonito's walls with the cardinal directions was always this deliberate. What changes as understanding accumulates is not the canyon but the observer, the person who stands in the morning light and sees, layered beneath the simple beauty of the desert dawn, the long, patient story of the human beings who stood here before. Let us return, one final time, to Fajada Butte. The butte stands in the early morning as it has always stood, solitary and unhurried, its layered sandstone walls catching the first horizontal light in the particular way that reveals the texture of the stone most clearly. The individual grains of sand that compose this rock were once loose sediment on the floor of an ancient sea. Compressed and cemented across millions of years of geological time, they became the stone that erosion slowly shaped into the butte we see today. The butte itself has been here, in recognizable form for far longer than any human civilization on this continent, longer than the ancestral Puebloans who carved their spirals on its upper cliff, longer than the earliest human presence in the southwest, longer than any human story we have yet found evidence of in this landscape. And yet, on the upper surface of this ancient formation, someone came, someone climbed, someone looked carefully at the way the morning light moved through the gaps between the stone slabs, and someone recognized in that movement of light a pattern worth preserving, worth encoding in the permanent language of carved stone, so that the knowledge of what the light did at the summer solstice, at the winter solstice, at the equinoxes of spring and autumn, would outlast the individual who first recognized it and be available to every person who came after. For as long as the stone and the light and the careful arrangement of slabs endured, that person, or more accurately, those people, because the knowledge that produced the sun Dagger was not the work of a single mind, but of a tradition accumulated across many generations, understood something fundamental about the relationship between observation and permanence. They understood that what is seen and then forgotten is, in a practical sense, as though it had never been seen at all. They understood that knowledge preserved in stone endures beyond the lifetime of the individual who possesses it, becoming available to the community across generations in a way that knowledge kept only in memory cannot guarantee. The spirals on Fajada Butte are in this sense an act of generosity. They are a gift from the people who first understood what the light was doing to every person who came after, including the people who walk through this canyon today and the researchers who study it, and the listeners who are encountering this story for the first time in this documentary. The knowledge encoded in those spirals was not hoarded or hidden. It was made visible in the most permanent medium available, in a location where the light itself would demonstrate the knowledge to any patient observer who arrived at the right moment. There is something quietly moving in that generosity if you allow the thought to settle. The morning light is moving now across the cliff face above the stone slabs. Not the summer solstice, not today, so the light blades that fall through the gaps between the slabs do not bisect the spiral's center in the precise way that marks the year's longest day. But the light is there, doing what it always does, moving across the stone at the pace that the Earth's rotation determines, neither faster nor slower than it has moved across this cliff on every other morning of this canyon's long geological and human history. Patient, consistent, utterly indifferent to whether or not anyone is watching, and yet someone is always watching in some sense. The stone itself is watching, or rather, the stone is recording the way stone records everything that touches it across sufficient time. The spirals record the cultural moment of their creation. The layers of the sandstone record the conditions of an ancient sea. The tree rings of the preserved timbers in Pueblo Bonito's roof record the rainfall of the years in which those trees were growing. Every surface in this canyon is an archive, a patient accumulation of the traces that time and process and human intention have left behind. We are very recent additions to this archive. The generations that built Chaco Canyon and carved the Sun Dagger, the farmers who managed the runoff from the canyon, rims the masons who shaped and placed hundreds of thousands of sandstone blocks. The astronomers who watched the horizon through season after season and gradually refined their understanding of where the sun rose on the mornings that mattered. Those people lived their entire lives in this landscape. They were born here or came here as children with their families, and they grew old in the shadow of these cliffs and under the clarity of this sky. The canyon was not a place they visited. It was a place they inhabited in the fullest sense of that word. A place they knew with the intimacy of daily presence, seasonal rhythm, and generational continuity. That kind of knowing is different from the knowing of researchers and visitors who come to Chaco Canyon for days or weeks or months and then return to lives elsewhere. It is the knowing that comes only from living in a place long enough to understand its subtleties. The way the light falls differently in different seasons, the way the wind changes character between canyon floor and mesa top. The way the soil darkens after rain in certain places and stays pale in others, the way the stars appear to move across the sky on summer nights when the air is clear and the darkness is deep and nothing competes with their light. This is the knowing that produced the Sun Dagger. Not a sudden insight, not a single moment of inspired genius, but the slow accumulation of intimate familiarity with a specific landscape across a span of time that required the contribution of many individual lives, many seasons of careful watching. Many small observations added to the growing body of knowledge that the community held in common. In the years since Anna Sophia first noticed the light moving across the spiral on that June morning in 1977, the Sun Dagger has faced challenges that its creators could not have anticipated. In 1989, researchers monitoring the site discovered that the positions of the three stone slabs had shifted slightly, enough to alter the light patterns that fell across the spirals. The shift was small, measurable in centimeters, but its effect on the precision of the solar alignments was significant. The summer solstice light blade no longer bisected the larger spiral with the same precision that had made the site so remarkable when it was first documented. The equinox and winter solstice patterns were also affected. The cause of the shift was, at least in part, the increased visitation that followed the public documentation of the site's significance. The narrow trail to the upper surface of Fajardo Butte, traversed repeatedly by researchers and visitors after the sun Dagger's fame spread, destabilized the surface in ways that contributed to the movement of the slabs. The very attention that the site attracted, the recognition of its importance that should have been its protection, was part of what changed it. The National Park Service closed Fajardo Butte to all visitor access in 1990. In response to this damage, and in recognition that the site's fragility required a level of protection that open access could not provide. The sun dagger can no longer be observed directly by visitors to Chaco Culture National Historical Park. The light patterns that Anna Sofia documented in the years following her 1977 discovery have been altered, perhaps permanently, by the combined effect of visitation and natural geological change. This is a loss, a genuine and irreversible one, and it deserves to be acknowledged honestly rather than softened. The most precisely calibrated ancient solar calendar in North America was altered in part by the consequences of its own discovery. The site that had survived nearly 1,000 years of desert weathering and geological change was changed within years of being brought to the attention of the modern world. But the loss is not complete, because the documentation that Anna Sofia and her collaborators produced before the shift occurred preserves a record of what the sun dagger was and how it functioned. The photographs, measurements, and observational records from the years of careful study before 1989 constitute a scientific archive that allows researchers to understand what was there, even though the original calibration of the site has been altered. And the broader pattern of astronomical knowledge embedded in Chaco Canyon's architecture, in the walls of Pueblo Bonito and the other great houses, in the orientation of roads and kivas and the other structures of the canyon, remains available for study and interpretation. The story of the sun dagger, including its alteration after discovery, is in this sense a complete story about the relationship between human curiosity and the fragile traces of the past. It is a story that contains both the extraordinary achievement of the people who created the site and the cautionary lesson of what happened when the site's existence became widely known before adequate protection was in place. Both parts of the story deserve to be told, and both parts have something important to say about how we relate to the ancient places that the past has left behind. The lesson that the most remarkable ancient sites are often the most fragile, and that curiosity without care can alter in moments what time has preserved across centuries, is one that continues to inform the management of Chaco Culture National Historical Park and similar sites around the world. The balance between sharing the significance of ancient places and protecting them from the consequences of that sharing is never simple, and it is never finally resolved. It requires ongoing attention, ongoing judgment, and the willingness to accept that some places are best appreciated from a respectful distance. Chaco Canyon, taken as a whole, remains remarkably well preserved for a site of its age and significance. The great houses still stand, partially, in various states of stabilization, but recognizably present in the landscape in a way that allows the full scope of the Chacan achievement to be perceived and appreciated. The road network is still traceable across significant distances. The astronomical alignments built into the architecture are still there, still functional, still marking the solstices and equinoxes in the quiet way that careful builders intended nearly 1,000 years ago. And the spirals on Fajada Butte are still there. They cannot be seen directly now. The butte is closed to visitors, and the light patterns on the spirals have shifted from their original calibration. But the carved grooves are still in the sandstone, still tracing the same two spirals that a careful hand pecked into the cliff face so many centuries ago. They are weathering slowly, as all stone weathers, and the day will come eventually when wind and rain and the chemistry of desert air have worn them to the point of illegibility. But that day is far away, measured in geological rather than human time, and for now the spirals remain quiet, patient, and complete in themselves, whether or not any light falls across them in precisely the way it once did. The sun is higher now. The long shadows of early morning have shortened against the canyon floor, and the quality of the light has shifted from the warm amber of dawn toward the clearer, more neutral brightness of mid-morning. The canyon in this light shows its geology most clearly. The horizontal banding of the sandstone layers the differential erosion that has created alcoves and overhangs, and the isolated prominence of Fajada Butte. The way the canyon walls catch and hold the light differently depending on their orientation and their surface texture. There are birds moving in the canyon now. A raven, characteristically unhurried, crosses the open sky above the canyon floor in the particular diagonal glide that ravens used to move between thermals. Smaller birds, juniper titmice, perhaps, or a canyon towhee, move in the scrub vegetation near the base of the canyon walls, their sounds brief and clear in the morning air. A light wind has come up from the west, carrying the dry, slightly mineral scent of desert air that has traveled a long distance across open landscape before arriving here. The canyon receives all of this with the same equanimity it brings to everything: the wind, the birds, the light, the slow seasonal turning that the sun dagger was built to mark. It has been receiving these things for millions of years, in one form or another, and it will continue receiving them long after the present moment has become as remote from the future as the Permian Sea is from us today. This is the quality that ancient places cultivate in those who spend time with them carefully. Not nostalgia, exactly, not a simple longing for a past that is gone, but something more like perspective. The recognition that the present moment is one point in a very long continuum. That the landscape we inhabit is older than our presence in it by orders of magnitude, and that the human stories we find most remarkable, the building of Pueblo, Benito, the carving of the spirals, the patient multi-generational accumulation of astronomical knowledge that produced the sun Dagger, are themselves embedded in a natural history so much longer than they are that they appear against that backdrop as brief and brilliant as a summer morning. And yet they matter. They matter precisely because they are brief, because they represent what human beings, in their particular span of attention and intention, chose to do with the time and the landscape and the knowledge available to them. The ancestral Puebloans who built Chaco Canyon chose to build carefully, to observe patiently, to encode their knowledge in stone so that it would outlast them, and to create a relationship with the sky that was precise and durable and generous in its willingness to share what it had taken generations to learn. That choice, that particular way of inhabiting a landscape and relating to the natural world, is worth knowing about. Worth sitting with quietly in the early morning while the light moves across the sandstone and the canyon continues its patient, unhurried existence beneath the enormous and clear desert sky. There is nothing more to add, really. The story has been told as carefully and as honestly as the available evidence allows. The questions that remain open have been acknowledged rather than papered over with convenient certainty. The living heritage of the Pueblo peoples has been recognized as the continuation of this story rather than its end. And the extraordinary achievement of the ancestral Puebloans in astronomy, in architecture, in the patient encoding of natural knowledge in stone, has been described as faithfully as words allow, in terms of what it actually was rather than what imagination might prefer it to be. What it actually was is remarkable enough. What it actually was is perhaps more remarkable than any invented version could be, because it was real and because the people who created it were ordinary human beings with the same fundamental capabilities and limitations as any person alive today. Working with what they had in the landscape they inhabited across the span of time they were given, they watched carefully, they built patiently, they shared what they learned, and the stone remembers. Stand here a moment longer before the day fully arrives. The canyon is waking around you in the particular way that desert landscapes wake, not all at once, not with the sudden bustle of a forest at dawn, but gradually and individually, each element of the landscape arriving at its daytime presence in its own time. The light strengthens. The shadows shorten. The temperature, still cool from the night, begins its slow climb toward the warmth of midday. Somewhere up on the face of Fajada Butte, closed now to all but the most carefully permitted researchers, protected from the consequences of the attention it attracted, the spirals wait in the morning shadow. The sun is not at the right angle today to send a blade of light through the gap between the stone slabs, but the sun will move, the seasons will turn, and at the right moment, on the morning of the summer solstice. As it has happened on the morning of every summer solstice, since someone first positioned those slabs and carved those spirals with patient, careful hands, the light will once again find the gap, and the blade will fall, and whether anyone is there to see it or not. The ancient calendar will mark another year. The canyon does not need an audience for this. It never has. The knowledge encoded in these stones was created by human beings, but it belongs in the deepest sense to the relationship between this landscape and the sun that moves above it, a relationship that existed long before any human eye observed it, and that will continue long after the last human observer is gone. We are visitors to a conversation that began before we arrived. And the most respectful thing we can do, the thing that the builders of Chaco Canyon demonstrated in the most durable way available to them, is to listen carefully, to observe patiently, and to pass on what we have understood to those who come after us. The morning light is fully here now. The canyon is warm with it. The sandstone cliffs glow in the particular gold of a desert morning, and the sky above them is the deep, clear blue that belongs only to high desert, only to places where the air is thin and dry, and the atmosphere itself seems to step back to allow a more complete view of the space beyond. It is a good morning to be alive in a world this old. It is a good morning to remember that attention, sustained across generations, can become one of the most enduring things that human beings create. Long after the day's first light leaves the sandstone cliffs of Chaco Canyon, the ancient stones will continue marking the quiet passage of time, just as they have for countless generations, patiently waiting for tomorrow's sunrise and the sunrise after that, and all the sunrises still to come. Thank you for spending this evening in Chaco Canyon. If the quiet landscapes of the ancient world, the patient stones, the careful builders, the long accumulated knowledge of people who watched the sky with extraordinary attention, help you find stillness at the end of a long day. History's sleepy time will continue to walk these paths with you. Subscribe to the channel so that our next journey finds you wherever you are resting tonight. Leave a like if this documentary kept you company through the evening. And wherever in the world you are watching from, whether the desert is close or very far away, thank you for your curiosity and for the patience to follow it all the way to the morning light. Sleep well.